All right, we're going to continue our classwork from night 7 on problem 7 here. We were in the middle of writing out the dependent variable based upon the rate of change, and now we're going to write out the independent variable. Our independent variable is in months, so that was the thing that we were told that was going to be equal to 2, and this is months since the beginning of the weight loss program. So I'm going to say MO period months since the beginning. And then the baseline, that would be the amount of weight, right? Because that would be in the dependent units. That's the amount of weight that he or she began the weight loss at. So this is 195 pounds. And once we have all of these things put together, it's very easy to write the linear equation because remember the linear equation is our dependent equaling our baseline, and then plus the rate of change. Remember, I like to abbreviate that with R of C, and that R of C then gets multiplied by our independent variable, and that's what we have our linear model built upon. So we have our dependent variable, which is W, and that's equal to our 195 pounds, our baseline, plus our rate of change, which is 4 pounds per month. Now, the only thing that we didn't add in here is that this is losing 4 pounds per month. So this is a negative 4 pounds per month. So this is plus a minus 4, and that's times the independent variable, and that's T. All right, there's our model. Now we can go on and we can answer part E or part F, which is to make a table of values. So the first value that makes sense is our y-intercept, 0, 195. And then we can put in 1 month. So at 1 month, right, this is equal to 4. So 195 minus 4. So at 1 month, we have 191 pounds. And then at 2 months, that would be 8 pounds, right? 2 times 4, which is 8. So 195 minus 8. So that would be 190 minus 3 more. So we would have at 2 months, we would have 187. And then one more time, we can do it again. This would be enough, but I'm going to just do a couple more here. So at 3 months, 3 times 4, which would be 12. And so now we would have 195 minus 12. 5 minus 2 is 3. 9 minus 1 is 8. Is that right? 1, yeah, and then 1. And then that's at 3 months. And then finally, 6 months, 6 times 4, which is 24. And now 195 minus 24. 5 minus 4 is 1. 9 minus 2 is 7. And 1 minus 0 is 1. And that's at 6 months. There we go. And so those are different values. Now notice that these change each time by 1. Right? That's a rate of change of 1. And then these change each time from one to the other by 5 to 1, which is 4, and then 1 down to 7, which is 4, and 7 down to 3, which is 4, and 3 down to, let's see, 3 down to 1. That's going to be a lot more because we went more than the rate of change of being an independent of 1. So right up till this point is where we're seeing the rate of change of the independent, or the independence being changing by 1, and the dependence each time changing by the 4 over here. Now this one, the independent changes by 2, and so this should be changing by 8, and that's exactly what we see, right? 8 over here divided by 2 here, which gives us a change of 4, and these are negatives, of course, and that gives us our rate of change, and that's what we're used to seeing. All right, we're going to continue our next and last video with the simplification problem that's in problem number 8.